Good morning, my dear students. In this session, we are going to learn about some properties of definite integrals. Let us move on to the first property. The first property is integral over a to b f of x dx is equal to integral over a to b f of t dt. Now we are going to check these two integrals are equal. That's what they have told. That is, if you are applying x is equal to, let us assume t to be x, that is substitution method, dt will be dx. So when there is a limit, if it is a definite integral, you need to change the limits. Therefore, when x is equal to a, t will be a. When x is equal to b, t will also be b. Now this integral, we are going to substitute this a, when it's x is a, t is a. When x is b, t is b. When x is, here you have assumed x t to be x, therefore substitute t here, therefore these two are equal. The next property is integral a to b f of x dx is nothing but minus integral a to b f of x dx. That is, if you interchange the limits, then you will be writing minus sign. The next property is, if we are introducing between 1 and 2, if you are introducing 1.5, that is between 1 and 3, if you are introducing 2, that is, you are going to separate into two parts, that limit into two parts. That's the next property. Integral a to b f of x dx can be written as integral a to c f of x dx plus integral c to b f of x dx. That is, from a to c. A to b is we are splitting into a to c and c to b. The next property is integral a to b f of x dx is equal to integral a to b f of a plus b minus x. That is, you are adding the limits and you are subtracting with x. That is f of a plus b minus x. Let us check how these two are equal. Now let us assume this is a board question and previous year board question. This they asked for 1 mark. In a 6 mark question, they have given 1 mark in 6 mark question. F of a plus b minus x into dx. This a plus b minus x we are assuming to be t. Here a and b are the numbers, so it is a constant. When you differentiate this, you will be getting dt equal to 0 plus 0 minus dx. Therefore, you will get dt equal to minus dx. Now, when you need to change the limits also, when x is equal to a, when you substitute a, you will be getting p. T is b. When x is equal to b, when you substitute x to be b, you will be getting t is a. So, in the place of a and b, a when it is a, it is changed to b. When it is b, it is changed to a. Now, in the place of x, what you can substitute? A, bring this x to this side, t to this side, a plus b minus t. And this is minus dx is nothing but minus dt. So, substitute minus dt. Take this minus sign outside. When there is a minus sign, what is the second property? When there is a minus sign, you can change the limit and write. Therefore, it is from a to b. You can change the limit a to b f of a plus b minus t into dt. Again, you are applying the property, first property, you are taking t to be x. When you take t to be x, dt will be dx. Therefore, substitute the upper limit and the lower limit, you will be getting the same limits. Therefore, a to b f of a plus b minus x into dx. This is also one of the important property. This property we will be applying when the integral is from, that is sum of the limits a plus b. When you add the limits to these two limits, the upper limit and the lower limit, you should get either pi or pi by 2. Then only you can apply this property. It will be so easy to solve this one. Let us see example 35. Take your book and take page number 345. Just I will explain. Evaluate integral pi by 6 to pi by 3 dx divided by 1 plus root tan x. As I told already, a plus b, when you add those two limits, those upper limit and lower limit, you need to get either pi or pi by 2. So, pi by 6, that is 30 degree, the upper limit is 60 degree, pi by 3, when you add, you are getting 90 degree. So, you can apply this. Now, this root tan x, what we are doing, you can write it as root tan x can be written as root sin x divided by root cos x. Therefore, 1 plus root tan x can be written as 1 plus root sin x divided by root cos x. After that, take LCM. Now, it is in 1, this is 1 plus root tan x is nothing but root cos x plus root sin x divided by root cos x. Therefore, 1 by 1 plus root tan x is you need to reciprocate and write. That's what they have written here. After that, what you can do if it is like this, you can write upper limit plus lower limit plus upper limit minus that x value. So, they have written in the place of x, you can write upper limit plus lower limit minus x. Here also in the place of x, you are substituting. Now, this is nothing but 90 degree, this is 90 degree, this is 90 degree. Cos of 90 minus theta is sin theta. Cos of 90 minus theta is sin theta. Sin of 90 minus theta is cos theta. That's what they have written here. After this, what you need to do is, after applying the integral, first you need to consider before writing, before substituting, you will be considering this to be first integral, and after applying you will be getting one more integral. That is, this is before applying the property, this is after applying the property. Therefore, two things. Whenever you are doing this, you need to add those first equation and the second equation. This is also I and this is also I. Therefore, I plus I, you will be getting 2I. And when you add it, that is root cos x plus root sin x divided by root sin x plus root cos x, numerator and denominator will get cancelled dx. After that, simplify and write. The next property is also the same thing. Instead of lower limit, they have given us 0. 0 to a f of x dx is equal to integral 0 to a f of a minus x into dx. This is also the same way. Take t to be a minus x and solve it and do it. This you will be applying when it is from 0 to pi by 2 or 0 to pi. As we have seen the previous sum, you will be considering the given question to be the first integral, and after applying the property, you will be writing the second integral. You need to add 1 and 2. This is in this question is example 34. Let us see example 34 in page number 345. Evaluate integral 0 to pi by 2 sin power 4x into dx divided by sin power 4x plus cos power 4x. See here always it's not necessary to apply the same property. So you need to decide where to apply the property. When it is like this, you may get. That's what I'm telling. It's not always. And so 0 to pi by 2. So in the place of x, what you will be writing? The property is in f of upper limit minus x into dx. Same way, therefore, in the place of x, what you can write? Pi by 2 minus x. In the place of x, pi by 2 minus x. In the place of x, pi by 2 minus sin. That is sin pi by 2 minus x the whole power 4. Sin 90 minus theta is cos theta. Cos theta the whole power 4 is cos power 4 theta. Therefore, here it is x. Therefore, it is cos power 4x. Therefore, this will also be cos power 4x. This will be sin power 4x. Now, as we have learned this one, you will be writing this to be the first integral, and after applying the property as second integral, always you should add those two integrals, and you should keep it in mind while adding the left. You should add the left hand side also, so you will be getting 2i there. Therefore, 2i equal to, when you add that, you will be getting this result. Therefore, this will get cancelled. You will be getting dx alone. After that, integrate dx and write. The next property, integral 0 to 2a f of x dx. Here you are introducing here, but for the second integral, for the first integral you are writing from 0 to a f of x dx. For the second integral also you are writing 0 to a f of 2a minus x into dx. Just go through the property, how they have derived in your book. The next one is also one of the important thing. If it is from integral 0 to 2a f of x, here also you will be applying for 0 to pi or 0 to 2 pi. When you apply this, why we are applying this property is, when we apply the limits, when we apply the limits directly, you will be getting undefined value. So only we are applying this. If you are applying 0 to 2a directly in the given integral, you will be getting an undefined value. You cannot integrate. That is, upper limit and lower limit will become 0. So you cannot integrate. So only we are applying this property. That is, if you are assuming f of 2a, 2a is nothing but the limit, upper limit, 2a minus x, if you are getting f of x. If you are applying 2a minus x, if you are getting f of x, then the integral is changed to 2 into integral 0 to a f of x dx. That is, if it is from 0 to 2a f of x, just you are assuming f of x. In the place of x, you are writing 2a minus x. If you are getting the same f of x, then this integral is changed to 2 times integral 0 to a f of x dx. If it is negative of it, f of 2a minus x is equal to negative of f of x, then the integral value becomes 0 directly. You can write it. The next question is odd function or even function. Here it is from the minus a to a. Therefore, the numbers are same, only it is from minus to plus. F of x dx. So it is from minus 1 to 1. If it is from minus 1 to 1 or from minus 2 to 2, you can apply either it's check whether it is an even function or an odd function. If it is an even function, what is the condition? This is the condition for even function. If f of minus x, in the place of x, if you are substituting minus x, if you are getting same f of x, then the integral is changed to 2 times 0 to a f of x dx. It is more or less same. These two are same, but this is called as an even function if it is from minus a to a. And if minus f of minus x is equal to minus f of x, the integral value becomes 0. This also you need to keep it in mind. Now let us go to example sums. The first question, this modulus, it is from minus 1 to 2, modulus of x cube minus x into dx. And whenever it is a modulus, I told you to equate to 0. Therefore, x cube minus x, when you equate to 0, you can take x as common. Therefore, x squared minus 1 equal to 0. Therefore, either x is equal to 0 or x is equal to x squared equal to 1. Therefore, x may be equal to plus or minus 1. Therefore, what is the limit? It is from minus 1 to 2. That's what they have given, minus 1 to 2. Therefore, it is 0 and plus 1 is also there. Therefore, the integral is from minus 1 to 0. You can split the integral like this. Minus 1 to 0, minus 1 to 0 and 0 to 1 and 1 to 2. That's for that only they have written. Whenever it is a modulus, you need to equate the value and find out the limits. How to separate? Now, between minus 1 and 0, the given function is positive or negative. That's what we need to check. Take any value between minus 1 and 0 and substitute in the given function. The function is x cube minus x. Let us take minus 0.5. When you substitute minus 0.5, minus half the whole cube, minus of minus half, what you will get? Minus 1 by 8 plus 1 by 2. 1 by 2 is nothing but 0.5. It is some value less than 0.5. Therefore, you will be getting a positive value. So, here you can write it as x cube minus x. So, it is positive of x cube minus x. Now, let us take a value between 0 and 1 half. Let us take half. 1 by 2 the whole cube minus 1 by 2. Therefore, it is 1 by 8 minus half. Therefore, minus 0.5 and a value less than 0.5. Therefore, it is negative. So, you have written minus of x cube minus x. And between 1 and 2, take 1.5. When you take 1.5, definitely this will be a positive value. Therefore, here they have written positive of x cube minus x. This sum is very, very important. This is this year board question. And integrate and write. The next question. Example 31, evaluate minus pi by 4 to pi by 4 from minus pi by 4 to pi by 4 sine squared x dx. As I told here, minus a to a. Therefore, the last property which you have seen, minus a to a f of x dx, you can write it as 2 into integral 0 to a f of x dx if f of minus x is equal to f of x, that is even function. Otherwise, if f of minus x is equal to f minus f of x, then the integral becomes 0, that is an odd function. So, here the function is f of x is equal to sine squared x. Now, substitute f of minus x. F of minus x, what you will get? Sine minus x the whole square. Sine of minus x is minus sine x. Therefore, you will get minus sine x the whole square is sine x the whole square. Sine of minus x is minus sine x the whole square. Therefore, it will become sine x the whole square, that is nothing but sine square x. Therefore, you are getting f of minus x is equal to f of x. If it is like this, the integral is changed from 2 into integral 0 to a f of x dx. Therefore, here they have written 2 times integral 0 to a value is pi by 4 sine squared x dx. After that, in second, third exercise we have seen, whenever it is a trigonometric function, cos squared or sine squared, you can apply cos 2x formula. So apply cos 2x formula and then integrate. Sin squared x can be written as 1 minus cos 2x by 2. After that, take 1 by 2 outside. So this 2 in here and here it will get cancelled. After that, simplify, separate the integral and then write. The next question, and one more thing I want to say, when the numerator you have x sin x or x into dx with the limit 0 to pi, you can apply the property f. Integral 0 to a f of x is equal to integral 0 to a f of a minus x into dx. That is the property which I have told here. When it is integral 0 to pi or 0 to pi by 2, you can apply, and when the numerator is x term or x into some term with the same limit. So here it is integral 0 to pi. When it is like this, I told you to, in the place of x, I told you to write pi minus x. Therefore, you will be getting pi minus x, sine of pi minus x, 1 plus cos pi minus x the whole square. Sine of pi minus x. It lies in which quadrant? Second quadrant. Second quadrant, sine is positive. Therefore, you will be getting sine x. Here, cos. So, cos of pi minus x, it is negative. So negative the whole square is positive, therefore you will be getting 1 plus cos x, cos square x. After that, after applying the property what I told, you should consider this to be the first integral, and after applying the property, this will be the second integral. When you add these two integrals together, that is x sin x divided by 1 plus cos squared x and pi minus x into sin x dx divided by 1 plus cos square, you will get this x sin x term 1 plus cos square will get cancelled. Remaining term is pi sin x dx divided by 1 plus cos square. So pi is a constant, so you can take it outside. When it is like that, you can write it. And one more thing you need to keep in mind, when you add it, you will be getting 2y. And here you need to take t to be cos x, dt will be sin x dx minus sin x dx. After that, change the limit also and integrate and write. Just go through this one which is given here. And the next one, example 33, it is from minus point to 1. This is considered to be f of x. When you apply f, check whether it is an odd function or even function. Here, when you apply minus x, minus sine of minus x, the whole power 5 will be negative. This will be positive, therefore it is a negative. F of minus x is equal to minus f of x, so it is an odd function, therefore the integral value becomes 0. And example 36. This is also important question. Evaluate, this you need to listen carefully. Evaluate integral 0 to pi by 2 log of sin x dx. Let I equal to integral 0 to pi by 2 log of sin x dx. If it is pi by 2, what I told, you can apply the property integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. So we are applying that here. The place of x, you can write pi by 2 minus x. Therefore, log of sine of pi by 2 minus x, that is, you need to write the integral I equal to integral 0 to pi by 2 log of sine pi by 2 minus x into dx. Now, sine 90 minus theta is nothing but cos theta. So, you can write 0 to pi by 2 log of cos x dx. Now, you need to consider this to be the first integral, this to be the second integral. Therefore, you will be getting 2I equal to integral 0 to pi by 2. When you are adding this, you can add the integrals, that is by algebra property, and you can add those two integrals. You can combine the integrals or you can separate the integrals. Therefore, log of sin x plus log of cos x into dx with the same integral, with the same limits. Therefore, 2I equal to integral 0 to pi by 2 log of sin x plus log of cos x dx. Log of a plus log b can be written as log a into b. Therefore, you can write log of sin x cos x. Since you can simplify this, if you have log of 2 sin x cos x, so what we can do, you can multiply and divide by 2 instead of multiplying and divide by 2, the same as adding and subtracting. You are adding and multiplying and dividing by 2 is also correct. If you are multiplying and dividing by 2, you will get log 2 sin x by log divided by 2. Therefore, log a by b can be written as log a by log b. Both are correct. So here you can write log of sin x cos x plus you are adding and subtracting log 2. So when you combine these together, you will get log sin x log a into log b. Logs 2 into sin x cos x, that will become logs sin 2x. And this is log to keep it as it is. After that, separate the integral here. One more step is integral over 0 to pi by 2. This can be written as log 2 sin x cos x. And separate the integrals here itself into dx minus integral 0 to pi by 2 log 2 into dx. Now this becomes log sin 2x minus integral 0 to pi by 2 log 2 dx. Now what we are going to do is, this 2x we are assuming this to be t. This is nothing but the value of 2y. We are assuming t to be 2x in the first integral, this integral. Therefore, when you differentiate, you will get 2 into dx is equal to dt. You need to change the limit also. When x is 0, t is 0. When x is equal to pi by 2, t is pi. T will be pi. Therefore, the integral, first integral, this alone you assume. Therefore, this is 2y. 2y equal to, what we are going to do is we are changing the limit when it is from 0 to pi. Therefore 0 to pi, this we are changing to t. Therefore log t, dt is nothing but 2 into dx. Therefore dt divided by 2 equal to dx. Therefore you are writing dt divided by 2, 1 by 2 you are taking outside. And here log 2 is a constant, so you are taking outside. Log 2 when you take outside, you will get integral over 0 to pi by 2 into dx. Now this dx, when you integrate, you will be getting x. When you apply the upper limit, you will get pi by 2. Therefore pi by 2 into log 2. Now why we are doing this step is, we can write this to be I. This is only the given integral. So we are going to convert the 0 to pi into log sin t dt to be 0 to pi by 2 log sin x dx. That's what we are going to do. Now for this, what we are going to do is, you are going to apply the property, that is integral 0 to 2a f of x is equal to, let me assume this, they have given integral 0 to pi log sin t dt. This is 2I equal to 1 by 2 times and minus pi by 2 log 2. What we are going to do, we are going to apply the property which is given here, integral 0 to 2a. Integral 0 to 2a f of x is equal to 2 times integral 0 to a f of x dx when f of 2a minus x is equal to f of x. This can be applied when it is integral 0 to pi or 0 to 2 pi. Since it is integral 0 to pi, we are considering this to be f of x. Therefore, f of x is equal to log sin. Here this is f of t. Log sin t. Since it is in terms of t, this is f of t. Now what we need to check, f of 2a minus x is equal to f of x or not. 2a is what? Pi here. Therefore, pi minus t equal to, in the place of t, what we are going to substitute? Pi minus t. Therefore, log of sine of pi minus t. Log of sine pi minus t lies in second quadrant. So, it is a multiple of pi, same trigonometric ratio. So, you will be writing log of sine t. That is nothing but f of t. Therefore, if f of 2a minus x is equal to f of x, then you can write it as this. Integral is changed to 2 times integral, this 2a becomes a, that is you are dividing by 2. Therefore, when you divide by 2, you will be getting pi by 2 log sin t dt. That's what they have given here. So, the integral is changed from 2 and 2, that's 2 and 2 will get cancelled. That's what they have written here as 2 by 2 integral 0 to pi by 2 log sin t dt, and this pi by 2 log 2 you are writing as it is. when you can change t to be x. You can take t to be x, dt will be dx, the limits will be the same. So you are writing this. Now this is nothing but the integral which is given in the question. Therefore this is I. Therefore in the place of 0 to pi by 2 log sin x, you can write it as I. Therefore here it is 2i. So 2y, this is nothing but I minus pi by 2 log 2. Bring this I to this side. Therefore you will be getting I equal to pi by 2 minus pi by 2 log 2. Therefore I is nothing but 0 to pi by 2 log sin x dx is nothing but minus pi by 2 log 2. This is one of the very important sum, and this is the continuation of 16th sum. 16th sum is also the same procedure. After proceeding 2 or 3 steps, you will be proceeding with this example. Thank you, students.